You find an interesting article, a dense PDF, or a long video tutorial, and you tuck it away in a digital folder, telling yourself you will read it later. But later never comes. For the average knowledge worker, the hoarding rate hovers around 93%. That means out of every 100 articles saved, maybe 7 are actually read. The hours spent tagging and sorting these files yield a massive negative return on your time. Curious, escaping this cycle requires a system capable of parsing the actual meaning inside your files. This is the AI second brain. A traditional note-taking app is a passive filing cabinet. An AI-powered second brain actively comprehends the text you feed it, connects related ideas across different files, and retrieves specific insights exactly when you ask for them. Ernest, true productivity requires abandoning the pure collection of information. Instead, the focus shifts to developing active intelligence from the materials you have already captured. The process starts with a simple capture phase. You take all your raw materials, PDFs, videos, meeting transcripts, and drop them into a single, unstructured inbox. Then, an automated agent takes over the process phase. The AI reads the text, drafts summaries, and assigns structural metadata on its own, completely eliminating the need for manual tagging. To get that information back out, the system relies on retrieval augmented generation, or RAG. This is the underlying engine that lets you search your process notes using natural conversation instead of rigid keywords. This chart illustrates a standard RAG pipeline, focusing on the character-based chunking step. Standard RAG takes a document and simply slices it up based on character counts, which strips away the author's original layout and natural structure. This next schematic details an alternative called link-aware RAG, or LayRAG. By focusing on the anchor-based chunking and metadata extraction blocks, you can see how this method preserves existing HTML hyperlinks and section anchors, creating a topological map of how the ideas naturally connect. Looking at this model response comparison panel, the performance metrics show a clear advantage. The link-aware approach consistently yields more accurate answers while retrieving fewer chunks and consuming fewer tokens than the standard method. When the AI processes documents with their structure intact, you can ask a complex question and get a custom, synthesized answer drawn from diverse media types, rather than just a disorganized list of blue links. The most practical architecture for managing all this data is called the LLM wiki pattern. It relies on plain text markdown files stored locally on your own machine. This setup guarantees your data remains readable by any software, completely preventing vendor lock-in. You connect an AI agent, like Claude Code, directly to this local folder. It runs in the background, acting as an automated librarian for your files. The workflow is straightforward. The agent ingests raw documents, writes structured wiki pages, and updates a central index automatically. Crucially, it performs a routine linting process. It periodically scans the folder, cleans up broken links, and merges duplicated concepts to prevent system decay. By letting the AI handle the repetitive editorial work, the LLM wiki pattern solves the long-term maintenance problem. You spend zero time organizing files, leaving you free to focus entirely on reasoning and output. But there is a hidden danger here. The moment you start building a second brain, the temptation to over-engineer the perfect system sets in. It is easy to fall into analysis paralysis. Users often spend hundreds of hours constructing elaborate taxonomies and folder hierarchies, instead of actually reading and absorbing the information they saved. There is also a psychological toll, known as the memory erosion effect. When you rely entirely on a complex external system to remember everything for you, your biological brain can stop internalizing new knowledge altogether. To avoid this, you need a minimalist stack. By using just one simple local storage tool and one basic AI retrieval tool, you flip the ratio, cutting down organization time so you actually spend your time learning. From there, establish a simple daily rhythm. Spend 10 minutes each morning having the AI surface yesterday's notes, summarize key points, and flag any unresolved blockers for the day ahead. The real objective is a friction-free tool that actively thinks with you, making a stagnant monument to organization unnecessary.